Suppose let us start with velocity time graph now. Suppose this is our y-axis, and along y-axis we are going to consider the velocity of the object, and along x-axis it we are going to consider the time taken by the object. So along y-axis we have velocity of the object, and along x-axis we have time taken by the object. Okay, and let us suppose that the graph of the object is something like this. Okay, and I am going to mark few points on this graph. Suppose we have a point on it like this. This is the starting point or origin of the object. Now this is our next point, this is our next point, and this is our next point. These are few points. Okay, let's assume, okay, let's mark these points. Suppose like this is the first point is the origin of the object. Suppose this is the this point represents the origin. It means the object is in state of rest when time was 0. Let's mark this point, on x-axis. Suppose it represents 5 seconds, and on y-axis one second, there is an error. And on y-axis, let's assume that this point represents the speed is 20, and on x-axis time is 5. Suppose time is 5 here and speed is 20 here. Okay, okay, let's mark this point and assume that it is 10 on x-axis and it is 30 on y-axis. Let's assume that, right? Oh, let me mark it 40. Okay, okay, and now look at this point to this point. If you just observe this point, like it is quite parallel to this point. It means its x-axis is changing. Like suppose x is 10 here, and maybe x is 15 here, and maybe x is 20 here. So x is changing. but y is same, so y is 40. Y it remains same, y is not changing. So because you can see, so just for the sake, okay, y for this point is here, similarly y for this point is also there, so y is same for these 2 points. That's why y is 40 for y is 40 for this point, similarly y is 40 for this point as well. Now let's calculate the gradient of any 2 points. I'm going to consider this point and this point, then we will consider this point. Okay, okay, before going to that, okay, now gradient means, the meaning of gradient is actually the change. Gradient means change in y-axis with respect to change in x-axis. And the second thing is of velocity time graph. It means velocity is along y-axis and time is along x-axis. In graph, velocity is along y-axis and time is along x-axis. So gradient of velocity time graph means change in y-axis with respect to x-axis. So you know that whenever there is change in v means velocity, change in velocity with time is called acceleration. So the gradient of velocity time graph will actually give us acceleration of the object. So it means we are actually going to find out the acceleration of the object. So calculating the gradient of velocity time graph means calculating the acceleration of the graph. So let's see. Okay, let's consider this point. At this point velocity is 0 and time is 0. When we move from here to here, now you can see time is changed and velocity of the object is also changed. So change in velocity, here the velocity was 0, now velocity is 20. So change in velocity with change in time, time is 0 to 5. So change in velocity with time is called acceleration. So it means for this point to this point, there is an increase in velocity from 0 to 20. So increase in velocity is called acceleration. So it means for this point the object is accelerating because there is an increase in velocity. Similarly, if we consider the object from this point to this point, you can see the time is changing from 5 to 10. There is a change in time from 5 to 10. Similarly, there is an increase in velocity from 20 to 40. So when there is an increase in velocity with time is called acceleration. So it means from this point to this point there is an acceleration of the object, or the object is accelerating from this point to this point. Now let's okay, so let us consider, let us mark these points with some numbers so that we can call them. Suppose this point is A. Okay, suppose this point is B. Assume that this point is C. Assuming that this point is D. Okay, so what is our conclusion? Our conclusion is that object is accelerating from A to B, the object is accelerating from B to C. Overall, from A to C, the object is accelerating. Okay, now let's move. Okay, let's write them. Let's write these points from A, and there is a point B, and there is a point C. And there is another point D. Okay, so the graph with our own observation says that it is from A to B, it is accelerating. For accelerating, I'm gonna mark it with A. From B to C, it is also accelerating. I am also going to mark it as small a. Small a means accelerating. And from C to D, okay, let's look at the C to D. Okay, from C to D, as see, the time is 10 and time is 20. There is a change in time. But look at the velocity. Here is 40 and here is 40 as well. So there is no change in velocity. No change in velocity means no acceleration. So you can see from C to D, there is no change in velocity. No change in velocity means no acceleration. So we can say acceleration for these 2 points is 0. Okay, so for our own convenience, we can mark it like if the graph is going is following this pattern, like going in upward direction, it means for a velocity time graph the object is accelerating like this. For a velocity time graph, if the graph is horizontal like this, it means acceleration is 0. Similarly, let me mark it. Suppose the graph is going like this. Suppose I'm gonna mark these points. This point is E. And for E, I can say time is approximately 30 seconds. And velocity is 0. You can see on y-axis the position of this point. On this point the velocity is 0. Like you can see, if we move from here to here on y-axis is 0 here, so we can say velocity is 0 at this point. Velocity is 0 at this point. Okay, so you can see, like now you can see the if the object is going like this, going in downward direction, here the object was going in upward direction. Like we are actually creating some tricks. So in a graph, if the graph is going in upward direction like this, it actually represents the acceleration of an object. But if the graph is going in downward direction, it represents the like you can see. Okay, let's compare the values. Time from 20 to 30, there is a change in time, but look at the velocity. It is 40 here and it is 0 here, so there is a decrease in velocity. Decrease in velocity is called deceleration. So it represents the deceleration of the object. So we can say, and deceleration is actually negative acceleration. So from D to E, okay, let me mark it as E here. And from E to like D to E, it is negative acceleration. Like from C to D, there is no acceleration. A to B, B to C is positive acceleration. Okay, so now let's verify every point with the mathematical calculations. Okay, let's calculate the gradient of AB. Okay, A is 0 0 and B is 5 20. A is 0 0 and B is 5 20. So gradient is, we know that gradient is m. How do we calculate m? y2 minus y1 over x2 minus x1. Okay, so y2 is 20 and y1 is 0 over x2 is 5 and x1 is 0, so it is 20 over 5. It is plus 4. So plus 4 means, okay, now let's verify that whether it's an acceleration or not. On y-axis it is velocity, and the unit of velocity is meter per second. On x-axis it's time, and time, the unit of time is seconds. So 4, the unit of 4 is meter per second square. So meter per second square is acceleration. So it is verified that the gradient of velocity time graph is acceleration. And now the one more factor is also confirmed, that from O to A it's a positive acceleration. Positive acceleration means the object is accelerating from A to B. So from, you can compare here, from A to B it's positive acceleration. Now let's move from B to C. B to C. B is 520 and C is 1040. So let's calculate the gradient up from B to C. Okay, so gradient is y2 minus y1, it is 40 minus 20 over x2 minus x1. So 40 minus 20 is 20 and 10 minus 5 is 5. Again it's 20 over 5 is 4 and it's positive. So positive, oh, unit is meter per second square. Okay, the gradient is acceleration. Okay, so before calculating these, we just observed the graph and found that from B to C the object is accelerating, and accelerating means positive acceleration. Now let's move from C to D. C is 1040 and D is 2040. Okay, so gradient is y2 minus y1 over x2 minus x1. So 40 minus 40 is 0, over 20 minus 10 is 10. So gradient is 0. It means the velocity of the object is constant. Okay. See, from C to D, by looking at the graph, we already found that the acceleration would be 0 at that point. Okay, now let's calculate from D to E. D to E is negative acceleration, means deceleration. D is 2040 and E is 30. Okay, now let's calculate the gradient. Gradient is y2 minus y1 divided with x2 minus x1. So 0 minus 40 is minus 40 and 30 minus 20 is 10. So it is cancelled. We are left with minus 10, and here is a minus. Minus means there is a negative acceleration. Negative acceleration means the velocity of the object is decreasing.